Hello, my name is Ryan Zins, RFID Product Manager for Diversified Labeling Solutions, and today we're going to talk a little bit about the on-metal and how tagging on metal applications applies to RFID. Some of the topics we're going to cover include why is metal such a challenge for RFID, some of the options that are available to us. We'll also discuss the advantages of each option and some of the disadvantages, and we'll also touch upon the printers and why on-metal labels are a little bit different for them compared to regular labels. All right, so let's start with why is metal such a challenge for RFID? There are two reasons, both are related to the physics of radio frequency or RF energy waves. The very first one is metal reflects these waves. As you probably imagine, if it's reflecting the waves away from the inlay, there isn't enough energy present for the inlay to harvest the energy, therefore activating the chip so the chip can report back to the readers. The other option is detuning. For those of you that are familiar with the old rabbit ears that used to be on TVs, we had to add the aluminum to the top and you had to move them around a little bit. It's the same thing here. These antennas are tuned for a very specific wavelength on the spectrum. If they come in contact with metal, or even if they're very close to it, it can detune them, meaning that they are looking for radio waves of a different frequency and they don't recognize the ones that the scanner is emitting. As you can tell, this would also be an option, so we have to address them in various ways. Okay, so some of the options that are available to us. There's really two main ones, especially that DLS deals with, foam back tags and the flag tags. We're going to discuss both of them a little bit further in detail, but those are pretty much the two main options that are available for on-metal applications. All right, so first option, let's talk a little bit about the foam bag tags out there. They are exactly what they sound like. The inlay is placed on a piece of foam, an eighth of an inch, maybe only a 16th of an inch thick, but it does serve to get the inlay out of contact from the metal. Sometimes when we're talking about RFID in the UHF world, we'll get a read range of 30 feet. With an on-metal tag, you're maybe looking at 10 feet. So for the right application, it can be the right solution, but read range is a concern. Another one would be printer issues. And when I say printer issues, because of the thickness of the tag, you may need a special printer or you may need to upgrade your printer to handle the printing of these tags in the field. Another is size is fairly fixed. For those of us in the regular label world, if we need a different size label, we just make a different size label. In RFID, or especially in on-metal tagging, if the size of the on-metal tag is 2.75 by 0.75 and your customer needs a 3x1, it's actually a lot easier and more cost-effective to help them redesign how they put their information on the label to make it fit in a 2.75 than it is to re-engineer the entire tag to fit a 3.1. The other option to the market is called a flag tag. It's what it sounds like. The label wraps around the substrate or attaches to the substrate, and the part where the inlay is flags off into free space, hence the name flag tag. Some of the pros with this one, the relative cost, especially compared to foam backed, is very good, much closer to a standard RFID label cost. Another one is it's much more easily printed. The printer issues we discussed for foam backed do not exist for flag tags. They get roll-to-roll printing. Most printers handle them right out of the box. Very easily printed. Custom sizes are optional. It's easier to customize the flag tag label, the ultimate end label, when a flag tag is being used. Another one is enhanced read ranges. Because it flags off into free space and is not relying on the foam back part to get its separation, we can recognize much longer read ranges. Also, some of them, the newer ones, have been re-engineered. They actually use the metal substrate as part of the antenna, and now we're talking relatively speaking, very long read ranges. It's a good option to consider. They are also, as a bonus, they are also excellent for tagging on liquid applications, which we'll talk about in a different scenario. All right, so some of the cons with flag tags. Durability can be an issue. If you think about it, the part that flaps off into or flags off the substrate can be subject to all manner of either shear forces, tear forces, can get snagged on things. If there's any humidity or water present in the area, it's more susceptible, and then there also is an adhesive edge to consider. The other one would be appearance. Sometimes folks don't want a flag flapping off their material. Definitely think of like an on-the-shelf application. The marketing department has set up how they want their product to look on the shelf. A nice flag hanging off the back may wreck the appearance that they're going for. Another one may be, or is definitely, that they have additional manual handling. If you think about applying a flag tag, it needs to be positioned correctly so that the proper portion is hanging off, the proper portion is attached. There may be fold over sections to help with protecting the inlay. There may be a perf that needs to be aligned. So it's just something to consider, that you may have more actual manual application with flag tags. All right, finally, let's talk a little bit about some of the printer challenges that I alluded to earlier. The main one by far and away is when you're printing on metal foam back tags, you will either need a printer that can handle them, or you will need to upgrade your current printer with an in-field upgrade for it. Currently, to my knowledge, the only ones right out of the box that are ready to roll are the TSC Printronics lineup. Other printer manufacturers have in-field upgrades that are available. We just need to make sure that you're aware that you need to have a conversation with your end user to check the printer spec sheets, make sure they can handle it.